Now, I want to expand the Young modulus equation as it relates to stress and strain. But before I do that, I will draw right here a force extension graph. Here is the extension, and here is the force. Now, here's the origin, and the graph can look like a straight line. Then, before you know, it starts to change behavior. All right. Now, this point right here, before the material starts to bend, is called the elastic limit. All right. So, from 0 to point A is the point where the force is proportional to the extension. So, from the 0 to A, as the force increases, the extension is increased. All right. So we call this point here, where the material stops or starts to bend, is called the limit. It's called the limit of proportionality. Limit of proportionality. Okay. Now, from this graph, we can find the gradient of this graph. And the reason why we have to find the gradient of this graph is that sometimes we'll be given a table of values and we'll be asked to find the Young modulus. So we can take our gradients from any point on this graph. Okay, so I can take my gradients from this point, I can take it down to the x-axis, take it down to the y-axis. Okay, now gradient is rise over run, and we know that gradient is the change in the y-axis, which is the force in this case, over the change in the x-axis, which is the extension in this case. So I can call this, let me call this my F2, and I call this my F1. Now here will be my x1, and here will be my x2. Now, to find the gradient of this curve, you can take your gradients from any point on this straight line. Okay. Now, to find the gradients of this graph, the gradients is equal to the change in the y-axis. In this case, is F2 minus F1. F2 minus F1 over the change in the x-axis, which is x2 minus x1 minus x1. All right, so this is how we find the gradient on this curve. And please note that the gradient is also known as the stiffness of the curve. It's also known as the word stiffness. So the gradient is also known as the stiffness of the curve. Now, what is stiffness? Now, stiffness is the ability of the material to return to its original shape or form after the applied force is removed. I repeat that. Stiffness is the ability of the material to return to its original shape or form after the applied force is removed. Now, let's derive an equation for Young modulus that we can use to solve questions. Now, we know that the Young modulus is equal to stress over the strain. And in our previous classes, we learned that stress is equal to force over the area. And also we learned that the strain is equal to the extension over the original length. Now we can put this into this equation and we can derive equations from this. Now therefore I can say that my modulus is equal to the stress is force over area, so force over area, divide by the strain. The strain is x over the original length. So therefore we can say that force over area. So in math we change division to times. So when we change division to times, we have to flip the right hand side. It becomes L over S. So this gives us the force times the original length of the material over area of the material times the extension. All right, so we can still rearrange this equation as it relates to the gradient. As you can see, the gradient in this case is equal to F over X, as you can see. So I can rearrange this to become the modulus is equal to F over X times L over A times L over A. Here is a new equation that we have right here, and I know that the force over the extension is also known as the gradient of the force extension graph. So I can replace force over S with gradient or with stiffness, because I said that the gradient of this force extension graph is also known as the stiffness. Okay, so therefore we can say that Young modulus is equal to, so I will replace this with stiffness or with gradients. So let me use stiffness, becomes stiffness times the length of the material over the area. So here is a formula we can use to solve for the modulus of a material. Sometimes you'll be given a table of values for force and extension, and we'll be asked to find the modulus of elasticity of the material. So the first thing we do is to draw a graph and to find the stiffness of the graph. Then we can now solve that question. Let's look at two examples on how we can apply these whole concepts.